Assalamualaikum and hi everyone. Today we are going to do revision on week 7. So we will focus on subtopic 3.1 and 3.2. So here are the questions or exercises for this subtopic. So let us solve these questions one by one. Okay, so question number 1, you need to find the domain for this function. Okay, fxy equals to x squared y plus exponent 3xy minus 10. Okay, so first of all, we need to know what type of function do we have here. For the first function, we have x squared minus y, x squared y, alright? So this function is categorized as polynomial, okay? And this function is categorized as exponential, and this function is constant. Alright, now for these functions, okay, there are no restriction of x and y, which means that any values can be plugged in into these functions. So we can say that the values of x and y can be from negative infinity up to infinity, okay? So we also can say that the values of x and y, okay, so the domain of x and y such that x and y is element of real number, okay? So you can plug in any values of x and y. So no restriction for this question. Okay, now question number 2. For question number 2, we have trigonometric function. We have sine, we have cos. Okay, so again, if you use your calculator, if you plug in sine negative 900, you still can get the values, right? The same thing goes for cos. If you plug in the values of cos, let's say cos negative 1000, you still can get the values, right? So again, the values of x and y can be from negative infinity up to infinity, or we can say that the domain of function fxy equals to, okay, xy such that x and y element of real numbers, which means that there are no restriction for x and y. So any values of x and y can be valid for this trigonometric function. Okay, next. Question number 3. Okay, this question is special because we have fraction. Okay, we have fraction. So this is fraction. Or in Malay, we call this as pecahan. Okay, in fraction, we have numerator and we have denominator. Okay, denominator ni pembawah. Okay, so in fraction, we cannot have denominator equals to 0. Cannot. So denominator cannot be equals to 0. Thus, okay, what we should do is we need to write 6 minus x minus y cannot be equals to 0. Therefore, negative 6 minus negative y here cannot be equals to negative 6. Or we can say that if we change the sign, the negative sign, we can have x plus y cannot be equals to 6. Like this. So we can rewrite the answer for the domain of fxy, x and y element of real number, but okay, we have x plus y cannot be equals to 6. So which means that this is the restriction here. Okay, x plus y cannot be equals to 6. Why? Because if x plus y equals to 6, the denominator will become 0. So this function will not be valid. Okay, this function will not valid if the denominator equals to 0. So that's why x plus y cannot be equals to 6. Okay, now let us proceed to question number 4. Okay, question number 4, we have a function of ln. Alright, a function of ln fxy equals to ln x plus 5y. Okay guys, for ln or log, okay, if you use your calculator, okay, try to key in ln 1. So this is not valid, okay, not valid. Ln -1, this is not valid if you use your calculator. And if you put ln 0.5, yes, valid. Ln 1 equals to 0, right? So yes, valid. But for ln, it cannot be negative number, okay? So what we should do here is, okay, in order to solve this question, for ln, x plus 5y must be always greater than 0. Okay, it also cannot be 0, right? Ln 0 also not valid, so that's why we have x plus y must be greater than 0. Okay, it cannot be like this, cannot. So it just greater than 0. I should erase this. Okay, so we have x plus y greater than 0. That's it. Okay, so domain of our function such that x and y can be any values, so element of real number, but we have restriction here. X plus 5 y must be greater than 0, like this. Okay, so this is the answer for this question. Alright, next question number 5. Okay, we have ln fxy equals to ln 6 plus x minus y. Okay, again, we know that inside here must be greater than 0. So we will have 6 plus x minus y greater than 0. Okay, so we will have x minus y greater than negative 6. Okay, so we need to change the sign. If you want to change the sign, you can have negative, okay, or you can change the sign as negative x plus y less than 6. Okay, therefore the answer would be domain of f should be xy such that x and y element of real number, but you can have negative x plus y should be less than 6, like this. Okay, so done. Okay, next question number 6. Question number 6. We have, okay, now we have square root sign. So fxy equals to square root sign 9 minus 3x squared minus y squared. Okay, now previously in ln, the value here must be greater than 0. Okay, but if you have square root sign, the value inside the square root, okay, the value inside here must be greater or equals to 0. We have equal sign. Okay, that's the difference between ln and square root sign. For ln, we just have greater than because ln 0 is not valid. But for square root sign, we have the equal sign here. Okay, so greater than and equals to 0. So what we should do now is 9 minus 3x squared minus y squared greater or equals to 0. So we have negative 3x squared minus y squared greater than or equals to negative 9. Okay, now you can change the inequality sign. Okay, if you want to change the negative sign to positive, we will have 3x squared plus y squared must be less than or equals to 9. Okay, therefore the answer of the domain should be the domain of xy such that x and y element of real number, but 3x squared plus y squared must be less than or equals to 9. Okay, that's it. Done. Alright, next let us move to question number 7. Question 7. Okay, we have fraction. So fxy equals to 2x sine 4x, 2x sine 4x over ln x minus y, ln x minus y. Okay, again, we know that the denominator cannot be equals to 0. Okay, here cannot be equals to 0. Okay, cannot be 0. Alright. So we have two conditions here. First, we know that in ln x minus y must be greater than 0, right? So we will have x greater than y. Okay, so settle for one part. But we also know that the denominator cannot be 0. And if we use calculator, we know that ln 1 is equals to 0. So we will have x minus y cannot be equals to 1. Okay, if x minus y equals to 1, we will get ln 1. Alright, so x minus y cannot be equals to 1. Therefore, x cannot be equals to 1 plus y. Domain of f x and y such that x and y element of real number, but x must be greater than y and x cannot be equals to 1 plus y, or x minus y cannot be equals to 1. Either one. Okay, so that's it. We have two conditions here. Okay, now let's take a look at question number 8. Again, we have fraction. So fxy equals to 6 exponent x plus y over square root of x squared plus y squared plus 1. Okay, again, this is fraction. So we know that the denominator cannot be equals to 0. Denominator cannot be equals to 0. So we need to ensure that. Okay, we need to write as this one. X squared plus y squared plus 1 cannot be equals to 0, and since this is square root sign, so it should be greater than 0 lah, of course. Okay, So we have x squared plus y squared greater than negative 1. Okay. So therefore the answer would be x, y, such that x, y element of real number, but x squared plus y squared greater than negative 1. Okay, in this question, we cannot have equal sign. Cannot. Because if we have equal sign, means we will get denominator equals to 0. That's why we cannot have this equal sign. So I need to erase this. Sorry. We just have greater than. That's it. Okay. So that's the answer for this question. Okay, next question number 9. Okay, we have a function. Okay, this question is quite interesting. Partial derivatives. So we have fxy equals to 4x to the power of 5 y cubed minus 10xy plus 6x squared minus 8y plus 7. Okay, now question number 9.1. We have del f del x, or you can also write this f subscript x, which means that, okay, if we differentiate f with respect to x, okay, I will explain to you about this. X is the variable and y becomes the constant. So you need to assume that if you differentiate with respect to y, you assume that y is the constant. Okay, so now let us solve this. Fx equals to, okay, we differentiate with respect to x now. So 5 here multiplied by 4, so we have 5 times 4 is 20, x to the power of 5 minus 1, so we have 20x to the power of 4. Y cubed is just a constant, right? Because as I mentioned earlier, if you differentiate with respect to x, thus y becomes the constant. So we just write it down here, y cubed. Okay, next minus 10xy. So differentiate 10xy with respect to x, we will get negative 10y. And then differentiate 6x squared, we will get 2 times 6 is 12x. Okay, and then now in this case, negative 8y is just a constant, the same condition as 7. So differentiate negative 8y with respect to x, we will get 0. And differentiate 7 also, we get 0. So this is the answer. Finish. Alright. Question number 2. We need to find del f del y. Del f del y. Okay. Or we can rewrite as fy subscript y. So in this case, okay, since we differentiate with respect to y, so we consider y as the variable. But now x becomes the constant. Okay. So if you look at the original question, okay, let me rewrite again this. The original question, sorry. I rewrite again the equation so that you can see the process. 5x to the power of 5, 4x to the power of 5, y cubed minus 10xy plus 6x squared minus 8y plus 7. Okay, now we want to differentiate this with respect to y, right? So fy, differentiate with respect to y. Okay, now the power of y here should be multiplied with 4. Okay, so we have 3 times 4, 12. X to the power of 5, just a constant, so we just copy it down here, x to the power of 5. But y becomes to the power of 2, because 3 minus 1 is 2. Next, negative 10xy, differentiate with respect to y. We will get negative 10x. Okay, and then now, this 6x squared. Since we differentiate with respect to y, so x becomes a constant. So you just assume that 6x squared is just like a number, let's say 10. So we have to, if we differentiate 6x squared with respect to y, we just get 0. Okay, we just get 0. And then if we differentiate negative 8y with respect to y, we get negative 8. And then next, if you differentiate 7 with respect to y, we know that 7 is just a constant. So yes, we will get 0. Okay, therefore this is the final answer for fx. Okay, next question number 3. We need to find del squared, del x squared. So this is equivalent as f subscript x, which means that we differentiate the function with respect to x twice. So previously in equation number 1, we have fx equals to fx 20x to the power of 4, 20x to the power of 4, y cubed, minus 10y plus 12x. Okay, so we need to re-differentiate this again with respect to x. Again, now y becomes a constant. So this 4 multiply with 20 here. So we will have 20 times 4 should be 80. X to the power of 3, y cubed, just a constant. So we just copy it down. And negative y, negative 10y, just a constant. So if we differentiate negative 10y with respect to x, we get 0. Okay, and if we differentiate 12x, we will get 12. So plus 12, that's it. This is the answer. Okay, question number 4. Question number 4 is we need to find del squared f, del y squared, or we also can rewrite this as f subscript y. So do we differentiate fy again with respect to y? So we will take the fy previously. We have fy 12x to the power of 5 y squared minus 10x minus 8. So differentiate this function again with respect to y. We will have 5 times, we have this 2 times 12 here. 2 times 12, 24. So x to the power of 5 is just a constant. Just copy it down here. And then y. 2 minus 1. We get y to the power of 1 only. Okay, now, since we differentiate this with respect to y, x becomes a constant, right? So since x becomes a constant, then we can, if we differentiate negative 10x with respect to y, we will get 0. Okay, in this case, negative 8 also a constant. So if we differentiate negative 8 with respect to y, also we get 0. So that's it. This is the answer. Okay, next, number 5. We need to find del squared f, del x, del y. So equals to fxy. Okay, before I forgot, actually guys, fxy is just the same as fyx. Okay, so it doesn't matter. If the question asks you to find fxy, actually fxy is just the same as fyx. Okay, now let's say we take fx first. So just now fx is 20 x to the power of 4y cubed minus 10y plus 12x. So now I will differentiate fx with respect to y. Okay, so if we differentiate fx with respect to y, now y becomes the variable and x becomes the constant. So we will consider the power of y here, 3, multiply with 20 here, we will get 60. So x to the power of 4 just a constant, so just copy it down, x to the power of 4, y cubed, so to the power of 3, 3 minus 1 becomes y squared. Okay, and then differentiate negative 10y with respect to y. So we have negative 10, but now guys, differentiate 12x with respect to y. This is just a constant in this case because we differentiate with respect to y. So x becomes a constant, therefore differentiate constant, we get 0. Okay, so that's it. This is the answer. Okay, next question number 10. Question number 10. We have fxy. We need to find the slope now, given that fxy equals to square root of 8x plus 2y cubed. Okay, or we also can rewrite this as fxy equals to 8x plus 2y cubed to the power of half, so that we can differentiate this easier. Okay, so the question asks you to find the slope in y direction. Okay, slope in y direction. Direction means you need to find fy. Okay, slope in y direction means you need to find fy. So differentiate this function with respect to y. Okay, now if you differentiate with respect to y, of course, we know that y, the variable, and x is the constant, right? Okay, you just assume that x is just a number, a constant. Okay, so now let us differentiate this function with respect to y. So the power here should be brought to the front. So we have 1 over 2, 8x plus 2y cubed to the power of half minus 1. So 1 over 2 minus 1. And then multiply, okay, multiply with, you need to differentiate inside this bracket with respect to y. So differentiate 8x becomes 0 because 8x is just a constant. But if we differentiate 2y cubed with respect to y, we will have 3 times 2y, we will get 6y squared. Okay. So we will get equals to, okay, now 6 times half, we get 3y squared. Okay, and then 8x plus 2y cubed to the power of negative half, or you can rewrite this as 3y squared over square root of 8x plus 2y cubed. Okay, we are not finished yet, because it said that we need to find the slope at the point of 2, 1, coordinate 2, 1. So at the point of 2, 1, substitute the values 2, 1 in this. So 3 times 1 squared over square root of 8 times coordinate x is 2 plus 2 times 1 cubed. Okay, so we will have 3 times 1 squared is 3 over square root of 8 times 2, 16 plus 2 should be 18. That's it. We have fxy equals to 5x to the power of 4, 5x to the power of 4 exponent to the power of negative 2y. Okay, the question asks you to find del cube f del y del x, or we can say that this is equivalent to f y x or f x y. Doesn't matter, we will get the same answer. Okay, so it's up to you. Either you want to differentiate with respect to y first or differentiate with respect to x first. Okay, so now let us solve this. Let us differentiate with respect to y first. So we have here the power of exponential, because if you differentiate with respect to y, x becomes a constant, right? So x becomes a constant, just copy it down. 5x to the power of 4, just a constant. Multiply by exponent negative 2y, differentiate with respect to y, we get negative 2 exponent negative 2y. So fy equals to 5 times negative 2, we get negative 10 x to the power of 4 exponent negative 2y. Okay, next we differentiate again with respect to y, fyy. So now again y becomes the variable and x becomes the constant. So we just copy negative 10x to the power of 4 because it's just a constant. So we just differentiate exponent negative 2y. So it becomes negative 2 exponent negative 2y. Therefore, we have negative 10 times negative 2. Negative 10 times negative 2, we get 20. X to the power of 4 exponent negative 2y. Okay, next, we need to find f y x. So we have, okay, now, since we differentiate with respect to x, so x becomes the variable and y becomes the constant. So we need to differentiate this x now. So 4 multiplied by 20, we have 80x cubed exponent to the power of negative 2y. Okay, finally, at the point of 0, 1, we have we have 80 multiplied by 0 multiplied by exponent negative 2 times 1. So of course we get 0. Yes, the answer is 0. Okay. Okay, last question. Question number 12. We have fxy equals to sine 2xy plus exponent 3x plus 4y. Okay, now let us find fx first. Fx differentiate with respect to x, so y becomes a constant. So now we should bring these two constant here, 2 and y to the front. So we will have 2y, differentiate sign, we get cos 2xy plus, okay, now since we are differentiating with respect to x, therefore 4y becomes a constant. So we just take 3, the coefficient of x to the front. So 3 exponent 3x plus 4y. Okay, next, find f(x)(x). Okay, differentiate again with respect to x. Alright, here, again, y becomes a constant. So 2x multiplied by 2xy, differentiate with respect to x. So 2y becomes a constant. So you just 2y multiplied by 2y. Okay. And then differentiate cos, we get negative sign, right? Or let me write like this. So that you can understand this better. 2y, okay, differentiate cos 2xy. 2y becomes a constant, so differentiate cos is negative, right? So negative 2y, just a constant, sine 2xy, like this. Okay, now plus, differentiate this exponential with respect to x. So 3 times 3 should be 9. Exponent 3x plus 4y. Okay, so therefore we will have negative 2y times negative 2y. We get negative 4y squared sine 2xy plus 9 exponent 3x plus 4y. Okay, that's it. This is the answer. Done. Okay, next. The question asks you to find fxy. Okay, guys, fxy. Okay, this is number 1. Number 2, fxy. Okay, so let me rewrite again fx. So we have 2y cos 2xy plus 3 exponent 3x plus 4y. Okay. Okay, now we want to differentiate this with respect to y. Okay, if you notice here, we have y here, we also have y here. So in order to solve this type of function, we need to use cross product. We need to use product rule. Okay, use product rule. Alright, so we assume that this is your u and this is your v. Okay, product rule said that let me erase this first. Product rule said that, okay, if you have multiplication of two types of function, we need to use product rule u v prime plus v u prime. Okay, so let us differentiate this fxy. So we have u is 2y, so 2y multiplied by v prime. So differentiate cos 2xy with respect to y. We will have negative 2x sine negative 2x sine 2xy, and then plus vu prime. So plus vu prime plus v is cos 2xy, and then u prime, differentiate u is 2y, so differentiate 2y, we will get 2. Okay, plus, okay, the exponential function, we can differentiate this exponential function as usual. So we have 4y as the we have 4y here. So 4 multiplied by 3, we will get 12 exponent 3x plus 4y. Okay, so let us expand this answer. We have 2y multiplied by negative 2x, we get negative 4xy sine 2xy plus 2 cos 2xy plus 12 exponent to the power of 3x plus 4y. Okay, that's it.